There is a website, http://SQL browser, SQLite, SQLite. So this is a light version, SQLitebrowser.org. Remember that there are three possible ways of accessing databases. Three possible ways. Usually, database engine provides graphical user interface these days. So it is easy to access using the graphical user interface. But I want you to understand always, not only database engine, but any cases, if it is a graphical user interface, then graphical user interface, any actions that you can choose from graphical user interface is a subset of the command line. Command line is a full set of whatever the capabilities that you want to use. Let's say if there's a database engine, then database engine provides you a vast amount of capabilities, a few of them, and also widely used to be visualized. There's a graphical user interface, and it is good for novice users usually. If you are an expert, then you need to use at the command line. At the command line, you can do all features of the engines. In this case, database engines. All features. There's no other features than you cannot do in command line. SQLite is a light version of a database engine. Actually, it is not an engine. It is just a library, if you want to say. It is a library, but still it works. It's not like as powerful as Oracle, for example. This is very light. So SQLite is available. Small devices where there is a Linux operating system is running. Can anyone give me example of such? All the smartphone has SQLites already there. iPhone, Android phones, which has Linux operating systems running, together with SQLite. So why SQLite is embedded? Many cases you need to save some data that may be created while the system is operated, or some data needs to be stored from the factory, so it should be accessed and reused many times if your program is not hard-coded. So SQLite possibly available in many home appliances. I didn't check. Well, they don't say, right? So there's no way that I can check unless I know internal sources. But these days, some electronic appliances provides a lot more functions that you need usually. So a lot of data stored there. And also you can set and unset And sometimes you can also add some additional data. So all such things is possible if you are running a small database. That is SQLite. Size of SQLite is very, very, very small. Right, Anthony? So download it. So practice these two. And then Python has a module that you can import. SQLite module. This module is not need to download it additionally. It comes with the Python. So we simply import it and also access SQLite database repositories. That is the third option of database access. Okay. As far as time permits, we will try all those three options. And also when it comes to, if you are, I'm not sure, but if not this spring, you may come back next spring if you want to stay by that time. There is a course 555 mobile technologies and wireless sensor services. The mobile technologies where we want to develop iPhone apps. Therefore, iPhone apps needs to create database and access the database already embedded in the Linux operating systems. Some apps do not need a database, but many apps may need a database. There are two ways of using database. Database already available on the device, which is SQLite. Or you need to always communicate the external database through Wi-Fi or cell communication. Well, anyway, that type of things will be discussed in that class. This is SQLite. Did you download? So quick download, right? Shivani, did you? Yeah. Already? Huh? Good. So on. Depends on your machine. Try to have both. If 64 is not properly working, then 34 always works for your Windows laptop. 64 sometimes there's some conflict. You need to check. Yeah. But not much difference, 32 and 64 in speed, performance. Price high, but not much improvement. Process itself doubled, right? But I'm not sure really. When you run some application programs, probably Chris, you had some data, statistics between 32 bit and 64 bits. I know. Let's say you have 32 operating systems running on a 32-bit process and 64-bit also. So you have two machines. Are they really that much different? For example, doubled in all aspects, performance and uh, maybe there's some test result conducted at the lab, but in reality, if you run some, but I don't feel much. 64 bits i7 process still so bad. That is my laptop. Doesn't matter. It is mainly operating systems. Windows, then it is Windows. Okay, Linux, then yes, it is a Linux. Windows is always causing problems and degrading performance and and finally we need to have a new version. Otherwise, a lot of defects come up. Okay, so this is very small version that you can download. What we will do, oh, 3.9 here. Download. Command line DL SQLite SQLite. Okay, very quick. So DLL unzip. This is only. Wait a minute. I need to go to different browser. SQLite browser.org. Okay, this is the version you might have, right? Okay, let's try. We can, although this is, as I said, this is not a database engine, but it is a database library. And also the graphical user interface makes you easy to access. But when you try to use database, then you need to first build the database. If you have an engine like this, let's say engine, then a database engine can serve one or more databases. Databases means that is the collection of database. There are three different definitions of all mixed used. Database management system, so-called DBMS. Database and database systems. So three different terminologies are widely mixed used. DBMS is a collection of packages. Management system, therefore, that is a packages. Database system means if you have a DBMS, that is a typical database engine, then it could have multiple systems to be built in it. So one of such a system is called the database system. Database system consists of all the capabilities plus repositories. So repository itself is called database, okay, in microscopic definition. Database is nothing but a collection of data. Database system, it is a system that can handling means creating, populating, and also accessing, like SQL, retrieval. Those things are possible. That is one system. That is a database system. DBMS is, although there is no data, we still call it DBMS. There is no instance of database, no instance of a system, because it is just a program, just packages. That's called a DBMS. Then what is SQLite? When you download this, brand new, it's called, you could say DBMS. But as I said, this is not typical engine, just simple library. As you can see from the name of this, SQLite. But once you have create database, then it'll be called database system. So within this DBMS, you could have one or more database systems. Each such has repositories. A repository is called a database. So we'll do that, okay? So let's create a new database. Let's take a look at a menu first. File, there are some menus, new, create, and open database. New database and open database. As you can imagine, new database is the database that you newly create. Open database is the database that already created. Now you want to re-access. Edit. What is a database? Database is a collection of tables. SQLite is a program that can handle relational database. There are multiple different modeled based repositories. When you populate data, then you need to have some models. If there is no rigid models, then that is non-traditional database. It doesn't care much about database strength, which means it doesn't care usually integrity of data, consistency of data, redundancy control data, version control data, and security issues. All valuable capabilities are missing. That's non-traditional. Why? Because there is no underlying model. If you say relational database, then the database should be built based upon some model, which is a relation. Relational model is dealing with the relation. Relation is kind of table. when you say table, but table is so a physical concept. Relation, not only physical concept, but it has some meaning, right? I have a table, therefore I have columns and rows, but it might have some relation, some um, some some relation with something else. That is called a relation. Okay, but you can simply uh, say the relation is a table. So when you create database, then you will have you need to creating a database starting with creating a table, because the database is a collection of table as far as the database is based upon relational model. If it is not relational model, what other models available? There are, anyone heard any other uh, database models than relational database models? Like 30 years ago or 40 years ago, there's a network database model, network database models. Now we all understand that network is very, very important. One data can communicate with another data, but at that time, network database model it came up and disappeared quick. When was it disappeared? Disappeared 30 or 40 years ago. There's a historically once available database models, network database model. Another database model is a hierarchical database model, functional database models, and they are discussing and implementing and over and over until early 1980s, when a relational database came up first. So there is a relational database. When we have a relational database, finally then we have SQL, SQL language. SQL language is good for well-organized databases. If it is not well organized, because it doesn't rely on any underlying models, non-traditional model, then there's no meaning to apply SQL. So we can simply say no SQL. Okay, no relational database model, then no SQL. After relational database model, so another models, object-oriented data model. Object-oriented data model came up mid 1980s or early 1990s. And then object-oriented data models had been discussed a lot more actively in Europe, and there are some implementations available. But there's always a problem in object-oriented database model. It's because there's no SQL is very, very strong language, but SQL is not powerful in object-oriented models. So late 1990s, about 15 years ago, guys in Berkeley and Stanford, his name is Mike Stonebreaker. He's now in Harvard University, and another guy is in Yale. They developed objective relational data model. Objective relational data model. From the terminology, you can imagine that, oh, that model is a combination between relational data model and object-oriented data model. Yes, it is, right? So you still use SQL language because the SQL language is a good tool, still used in a relational database. Object-oriented data model has also its own strength. It can represent almost all the real-world situation because it is treated everything as objects, and objects are related to each other, which is not available in relational database. But anyway, so that is where we are currently. So if we use a relational data model, then it is not quite far from object relational database. So anyway, in order to create database, we have to first create table. And there is a menu called the create table, modify table, and delete table. Another view. Once you create a table, therefore data inserted into it. So data available in your table. If you have more than one table, then we can say it is a database, relational database. Then we want to see it, how to view. There is a very good language called SQL. So we can see the SQL, okay? Predefine the buttons below, new database, open database. So now we want to do a new database. If you click new database, then you need to create some file name, right? So I can say, where can we save it? If we want to save, your 505 directory, then you need to find out there, and then I would say OSDB. All right, and there is, okay, this is the right place, so that I can put here and your last name and 15F fall 2015. That is a file name. And then you need to now create a table. Start with a table, right? So you can say table, as we looked at the last time, in our what we did, I want to have this, the first slide of that. Well, let me close this and say, what is my database? Okay. Make sure that on top of that graphical user interface for SQLite, there is a path to the file that we just created. I hope you can find it, yours. In my case, the C:/mercy 505 OSD/yun15f. Okay, right there. And then we need to now struct database. Database creation starting with the table creation. So that is a create table. So that is that. Now I have more space. All right. So let's create students table called student. I wanted to look at the bottom here. This is the language. This is a data definition language, so-called DDL. Right now, what we do is we use graphical user interface. So we do not actually executing this kind of statements or command, but if you do not have a graphical user interface, you should actually type this command, this statement, to create a table. That's what you need to do. Right now, we want to use graphical user interface first. So there is a button called Add Field. To this student table, we can add multiple fields. From our design only, last week, student has a CWID, age, and major, right? So we have here field. Yeah, first field, the field name is, can say CWID. That is an integer. And we can add another field. Double click here. Then you can see age. That is the integer. And add another field. You can say major. Major is not integer, but text. Type here. When you click the type for an attribute or field, those are the types available in this SQLite. If you have a different engine, database engine, then you have more powerful data types available. Very, very primitive data types. Integer, text, real, and number. Real is floating points. So we have some fractions, 2.5, for example, then that is a real number. If you say number only, then don't care the number. But there is another type called the blob. What is a blob type? Blob, B-L-O-B, blob stands for binary large object box. Binary large object box. What do you think the data, what would be an example of data that can fit in this type if you choose it blob data type? For example, photo, right? Picture, then that is a binary large objects. Video, that is a binary large objects. Depending upon database engine, there is another data type called CLOB, C-L-O-B. Can anyone imagine what C stands for? B for binary, C for character. If you have very large documents, it's not just atomic value like the first name, then John. It's not like that. But full one textbook, 400-page textbook. There's characters. But character, but very large objects. CLOB. That's available in another type of database engines, but not here. So what we will choose here for major is text. So we can do that. If we want to make CWID as a primary key, after this, there is a not PK AIU default to check. So PK means primary key. Primary key means if I choose this as a primary key, then what is a table? Table is a collection of data, right? You can say a table is a collection of row, not the column, rows. You can also define a table is a collection of columns. But right now, let's say a table is a collection of rows. Each row should be, it's not a good idea that you have multiple identical rows in a table. Then eventually integrity cannot be preserved. Why? Because if you change one row with the other rows with no change, then there's an inconsistency occur, right? But anyway, so if you want to keep the data non-identical, non-redundant, then you need to identify, hey, this row represents this object. Another row represents a particular another object. If that is a student, then hey, this row is talking about James. Another row is talking about Anthony. Another row talking about whoever, right? You should not say that, oh, this row is talking about you, but I have another row. This is also talking about you. Then your database already lose integrity. Then there's no reliability there, right? To avoid that, we need to set primary key. So there is only one record, one row exists with this key. For example, CWID, then there should be only one record for one CWID. Therefore, we can say that, oh, this record is particularly you. There's no other person can say that is his or hers, right? That is the primary key. So if you click this PK, then look at this language so far. The language so far that you can see here, create table, students, open parenthesis, CWID, type integer, age and comma. So you might list multiple pair of field and type. So age in integer, major in text, and then before we close the parenthesis, primary key is the CWID. It means when you enter a new data, if there is already the CWID, the same as you now want to add, then your addition will be declined. In that way, your database keep the integrity of data. Not means, back to this graphical user interface. If you say not, then that is called not null. CWID is a unique, but it should not null character, should not be null character by clicking this, which means there's no students who do not have CWID, right? If we do not this, if we unclick this, then we have only primary key. Primary key checks, ideally checks non-null and also uniqueness by default. But if you want to say more explicitly, this should not be null, then you can click not. U means unique. That's very similar to primary key, right? So such things. For example, major, there is no non-declared major available. Then you can say not. Then there's no students who do not have no major. Age should, yeah, something like that, if you want to choose. If you click more, then your data is more rigidly controlled and managed, which is good, but at the same time, flexibility becomes very, very low. Okay, so you have to design very carefully. Once you have this, then I think you can do OK button to save it. Then you have one table. And you can do browse. Click this. And right now there is nothing. But you can enter. For example, CWID 1111. And then age 21. Major, oh, there's no name. It's okay. Major CS. And then there is a button on the upper right corner. You can delete record or you can create a new record. So create a new record. Oh, wait a minute. You should not do this. Right? This is new. Okay. So here, create. That's okay. So CWID is 1 and you can leave it there. age 21, major CS. You can create new automatically. It says it increases. That's okay. Over 22, major cyber, CSCC, cybersecurity. Another, you can change this if you want, say 33. And then age 29 and CSAC and something like that. Okay. Here, so right now we have one table and how many records? 3 records. We can create more table if we want. So create table called course. So add a field. I can say course title. A little bit of integer and title and credit. Credit is integer. Title should be text, and this is primary key. So enter. So for course, we can also browse data. Wait a minute. Okay, browse the data and click course. I need to create new title. For example, database. Credit, 3 credit hours. Another new record. If I say database again, what happens? It says error. Why? Right, I put it as a primary key. Title is a primary key, which means it should be unique and non-null, right? So, so we can do here operating system that is 3 credit hours, for example. So course, we have two courses available, and there are how many? 3 students. 29. Oh, this was not saved. Also CSAC. Enter. And very clearly that you can see when I create this, then you can see the SQL log. These are the SQL that I so far entered. Okay. So you can create, we can add a new record, 34, age 23, major business, something like that. So 4 students and 2 course. What we want to do is students and courses. We have 2 tables. As you look at so far, title and credits for course and CWID, age, and major. If you see those 2 tables, definition of those 2 tables and the data of those 2 tables, there's no relation at all. 2 separate tables exist, right? So in database, you probably need another table. What we want to do is that we want to have data. Therefore, we need to see who are in my student table and what courses are offered. Plus, who takes what courses? How many students enrolled in a particular course? So all those scenarios can be possibly obtained. But to do that, we need to have one more table. The table needs to link between students and course. Right now, students and course, 2 tables are independent. There is no relations. But actually, in academia, there should be relations. Course and students are related through, in many ways, but in this case, enrollment, for example. Okay, there is a possible relations. So table called enroll. And we can add field. And that enroll, what should we do? Students, we need to say students. So who comes in my course, right? That should be determined, should be represented. So in this case, course. Course is, I want to say text. And enter. So very nicely, we have 3 tables available: course, enroll, and students. So we can say, oh, this course has this kind of students who are enrolled in. That's what we want to represent. So go back to browse data. Now we can say enroll. We can say students Bob takes calc. Enter. That's possible, right? Why it is possible? Well, first of all, yes, it is possible, right? Systematically. In reality, should this be allowed? Because there is no students in my student table, no class in my class table, but somebody says, I want somebody from outside and came to my database. I want to register this course, which is not provided by my database either. But in this case, that is possible. So we missed some, right? So we could delete this, go back to our database, and enroll. Open this. And modify table. Come back here, students, and then we need to have somehow we need to specify this is water, not this. This is not primary key. What we need to do is not provide here in this graphical user interface, right? As I said, the graphical user interface is a subset. So what we need to do is, can we add it? No, it's not available. But anyway, let's leave it like this, and then we'll go back to the command line. Okay, it's okay right now. All right. And then let's try to execute. In this SQL, the simple SQL is this. Select star from students and semicolon. Enter. And if I want to execute, then there is a button so that I can execute. What it does is that this means I want to retrieve, star means wildcard. I want to retrieve everything from students. So this is nothing but, can I see whole content of the table students? That is this, right? If you change this to, for example, course, and execute, then you can see the courses, those two courses. All right, there's a typical SQL. Another SQL is that, oh, can I see who enrolled in what course? Then you can say course, comma, student. What do you expect from this SQL? The idea here is that SQL, the idea behind issuing that SQL is that I want to see who enrolled in what course, right? So I want to select a star from those two tables. We already know the data populated into this. So who enrolled in where? Nobody, right? If I removed that record. Nobody. That is what we need to expect. But this language itself, watch this. What it returns? Yes, very well. Not too bad, but So you take what, Dubai. What is the name of the country? Dubai is the city, right? Oh, Arab Emirates. Somebody said that their airplane is the best. Current is not bad, but when I go to Europe, I can go only during summer, which is very high fare rate. So I choose the cheapest. Cheapest is still over $1,000. If I go to any place in Europe, sometimes 1,500. So expensive, the cheapest air. Because it's the cheapest air, the quality is really bad. I don't say which national airlines, but very bad. But somebody said Arab Emirates. Who said that?
I wish you speak out.
They don't even provide all travel expense.
Oh, when you're doing like,
Yeah, some
business
presentation. Yeah, then they support partial air, and then the rest my own. So if you go, then I should always plan spending my money. So broadly, school, if we make presentation on behalf of Mercy, then they support not more than 50%. If we save, if we make all cheap, then maybe close to 50%. But if you take little better ones, then 20%, 10%. Okay. So now, have you thought why this happens?
First, we wanted to display course, and we wanted to display students, so display the course and then each student inside each course.
Okay. So what Eric said is that if you don't do anything but this kind of language, then it combine all possible matches, all possible match.
Would it be the same if you were switching? If you were to do student then course, would it be the same?
Oh yeah, same. I mean, different list of only order difference, but number of the records remains the same. What happens is how many? How many records? 8 records. Then you can get some clue. How come we have 8 records? How many courses? 2 courses. How many students? 4 students. So 2 times 4 is 8. What happens here is that if we don't do anything but just list 2 tables and retrieve all, then it make all possible combinations. 2 times 4, which is 8. So I have 8 records. If you want to retrieve meaningful match, in our case, 0 enrollment, right? Then you need to have another condition, starting with where, and then you need to match. Which one should be common? Which one should be common? If you see here, look at the course and students, and we have two definitions of those 2 tables. Definitions of those 2 tables. Course has title, course title, and credit. Students has student ID and age and major. We need to pick at least one field from each and then link them together. Otherwise, those 2 tables are independent. What it means is that by linking fields, by linking attributes, at least one attribute from each, those 2 tables can be related to each other. Which one could be? What we did here, right now, yeah, actually what we could do, yeah, we do not have anything, course and students, right? We can include more here, enroll. What happens if we have enroll? Nothing. Of course, there's no ones. But if I have enroll here, let's say create, and who's who? Students say student ID 1, right? There is a student ID 1, and course, there is database. Okay, enter, and come back here. I want to execute it. Immediately, suddenly, how many? I have 8. What happens? 4 students times enroll times 1 enroll times 2 courses. So 2 times 1 times 4, which means 8, right? But if I do one more enrollment, for example, number 1 still takes operating systems. Come back here. If I click the same thing, how many tuples? 16 tuples. What happens? 2 students times 2 enrollment times 4 students times 2 enrollments times 2 courses. So 4 times 2 times 2, 16. Right? 16. But it doesn't make sense. In what way it could be sense is in this way. I want to now link. How can I link? I want to link, for example, look at this. If you look at enrolled, then there is a student. I want to link this student information with the CWID in the table students. I want to link course in the enrollment to the course title in the course table. Do you see that? So student here is the same as CWID there, and course here is the same as the title in the other course. What did we say that in the definition in the theory of a database? We call it not the primary key, but foreign key. It's not a key. For example, student and course is not a key here. But this guy, student, was key in the student table as an attribute CWID. Course here is the key in the table course, the attribute title. So we have to now, because we have meaninglessly many all possible matches of tables. Now we want to make it sense by linking the meaningful field names. As I said, title in the course should be the same as the course in the enroll. So title here is the title from where? Course. Course title should be the same as enrollment course. And we can say student dot CWID should be the same as enrollment student. So I link. What happens here is that student CWID, I do not have here enroll, but if I redo this, I want to redo this like this, delete all to make it more simple. Okay, I have here students, and class called the course. And then I have enroll, and I have student and course. Okay, so course has title, text, course has title and credit, right? That's what we have. And then enroll has a student and integer, and course has text. Okay, so those three tables are created as you look at, right? Those are three tables. So we have three tables. When we do SQL, if we do not have this, then we have a meaningful outputs, meaningless outputs. So to make it sense, we need to now connect the common attributes. What are those common attributes? The common attributes are in this way. I would use this. Student here is the same as that. And then course title is the same as the course here. Okay. So title here itself is a primary key on the line. And then CWID itself is a primary key. But in the enroll definition, student itself is not a key, but students was a key in the table originally. Similarly, course in the enrollment is nothing. It's not really a key. It is a regular attribute, but it was the key in its own original table, which is a course, right? In this case, this students is called the foreign key. Students is a foreign key. Course is a foreign key also, right? So we want to link CWID from students to the students from enrolled. Similarly, like this. So what happens if I execute it? No such column, students, some errors here. Course, which one? Course. Let's say course, title, student, CWID, enrolled, student, not students. Okay, student. Here is not student, but student. All right, and execute. Now we have very meaningful information, which means CWID1 takes database. The same person takes operating systems. That's what it is, right? That's what we could see. Number one takes database, and number one takes operating systems. That's what we have here. This is the language. This is SQL language. What it does is that three tables are joined So actually it is called the join operation. In database, join operation can be further analyzed, and therefore not only at this level, like a high level language, but we could theoretically investigate the algebraic level in database context. But we do not do that here. Okay, so this is the language SQL. This is whole point of using graphical user interface. Okay, now what shall we do? Command line. In order to do command line, I'll leave this here, right? So that we can compare. You need to open up a command line. See here, like this. And in my lecture somewhere, this is graphical user interface, and this is the command line. You need to start with SQLite 3 command so that you can have. What I want to do is I want to go to the file that I stored, the database file. What is the database file? This is the database file, right? That I created today. So SQLite 3 transient memory. So right now is a transient in-memory database. If you do not want, I think this is the command, right? Dot. Start with dot. SQLite followed by, let's see. Oh, we don't need to. Simply database. That's okay, right? Let's try as is. So SQLite 3, and then we can say database. Dot database. What is the command? Databases or database? Database, fine. So if you type database, then I have one main, which is not the database that I want to do. So quit. Yun 15. I'm not sure. Works. Table. It's not. What is? Wait a minute. I didn't. Did we save as a database name? Oh, we didn't save as a database name. Do you want to save the yes open database? Okay, so it is there, but not the database name itself. some mistake. So okay, let's go back to this, that, and then help. We need to connect to database. Backup clone database list name is database echoes okay. Oh, now we have tables. Okay. Dot table. Then we have three those. So table and course. Then I have that. And then what are those? Those are the command. So we can see, okay, schema. If we want to see the schema, then this. CHEMA, schema, and then table name. Student, then we can see the student table. As we created, right? These are the student table that we created here. Student, CWID, AG, and major, that is that. If we want to see schema course, then you can see also title, credit. That. And then the similar way that you can select, you can you can issue SQL, select a star from student. By the way, database language is not case sensitive. And it should end with the semicolon and hit enter, then you can see this, which is exactly that you have here, for example, student, then that is this, right? This is a student table content, 121 CS, and so on and so forth, that appears here in this. If we want to see select star from, I do not want to see all three, but I want to see let's try to create table. Create one more table called name table, and then we have not name table. You can say profile, because we have here only the code, the CWID, and then those things. We do not have what that person is. So let's say first name, there's a text, and then second name, no, not second, last name, that is text, and then we can say CWID, that is integer, and simply save it. So that if we want to see schema profile, then we can see that. Okay. As we populate the data, we can also populate here, insert into profile values in that order. Say first name is John, and then last name is Smith, and then the CWID is number 1, and enter. Therefore, we can see start from profile, then we can see John Smith number 1. What I want to do here, when I do this, select start from students, then I have number 1, 21 CS, right? Can I do, for example, the list of students with the major only? Can I do that? Then instead of a wildcard, I need to say student first name and then major from first name, the attribute first name from what table? Profile table, right? So you need to say profile. And the major from where?
First, I don't know if first is going to bring up. You get a typo when you entered when you created a table. You left out the R, so you might have to change it. Select.
Oh, fist.
Yeah.
Yeah, it should be the same as that. Okay. Major, and then the other one's profile and students, right? Again, if I don't do any condition here, then what happens? It returns all possible combinations. Returns all possible. John in CS, John in C6, John in C6, John in this. Doesn't make sense, right? To make it sense, what happens? Then I have to do where condition and link those common attributes. So which are the common? You need to look at, now we have a profile here. Which ones are common? There's profile and students here. CWID is a common, right? So what you need to do is student CWID is the same as profile.CWID and semicolon, enter. Then we can clearly see John is in CS major. Why John is in CS major? Because what it says here, number 1, CWID number 1 is a CS, but number 1 is, by the way, nothing but John. Where is it? Here. John Smith, CWID is number 1. Okay. So what is the issue? What is the issue? Here. SQL statements should specify if you want to join, then you need to have the connection, linkages over the common attributes. Otherwise, it'll return all possible combinations, right? Then someone may ask, why we have that all possible combinations, that capability available in database? Anyway, it doesn't make sense. Why create language that make perfect sense only? Why? Yeah. Very strange, right? but there is some rationale. Database should show all possible scenarios. What happens is that database assumes the closed world assumption, closed world. Therefore, we're not going to ask only the positive scenario. We need to ask negative scenario. For example, oh, are there any students who do not enroll? Sort of a negation. Negative expressions needs to be taken care of. In this case, not only sense of a match, but by having all possible combination, we can say who are not met at such condition. So some negation, some complementary situations, many times needs to be retrieved, right? If you go to bank, so credit card companies, oh, I paid such transactions. Some other cases you might ask, oh, which ones that I didn't pay so far? So a lot of negations, negative situations needs to be supported from a database. So by default, if there is no condition attached to this SQL statements, it returns all possible combinations. And there is, of course, a room that you can make it sense so that you have a positive mapping. And therefore, you could have negative mapping as well. Okay, that is the issue. So now you could see this is a command line. If you create the command line, like insertion and creation, you could see here in graphical user interface, right? Any question, any issue so far? Command line? Anyone need help? I can help you. What I did here is that at the very first time, when you enter, not only SQLite 3, this is the command, but the database that we created. This is database file. So you need to go to the directory where there is a database file. If you want to first create and save your file right there, then that's fine. You can do this anywhere and create your database and save it. How can you save it? There is called the save file, .save file. Okay, this is simple ones. Only what's left undone is Python. Okay, so let's open the Python textbook. I think that is it. Okay. Accessing database servers. As I explained, 3 ways, right? Oh, wait a minute. No, I didn't say that here. This is only for Python. So to connect database from your host language, these are the steps. You need to first connect database. From your language, there should be connection between your language and database. There's two different products, right? So you need to connect. And then construct a cursor object. This object is a reference to that database. By creating an object of that database, from that time, you can always reference to that database. So whatever the command that you could use, that command is executed against to that object, which is to that database. Therefore, we need to construct a cursor object here. Once you have a cursor object, then you can create table, you can insert data, you can issue SQL statements, and finally, that may not be the case here, SQLite, but if you use some other large formal DBMS like Oracle, then you need to commit. Commit means is this: when you run a database, when you connect a particular table in the database, then few pages of that table, page in this case, minimum size of data fetching, right? Few pages should be loaded in memory, and you change, update the portion of table on that memory. And finally, if we want to make it persistent, then you need to flush that memory space to the storage. That is nothing but commit in database language. Okay. Here's an example. Okay. So what we will do is we're going to now practice this. Okay. So terminate this SQL3 is .quit. Okay. In Python, quit, open and close parentheses. In SQLite, commands start with dot. So you can see all possible commands within this command line. Look at this, all start with dot, right? Dot help, all dots. Okay, dot quit. Now we need to switch to the Python. Let's do Python command line, okay, rather than creating that. So see Python 34 / Python, where I have in this directory where there is a yun15f database file. Enter. And then we need to do import SQLite 3. No problem. And then I need to connect database. SQLite 3 dot connect command. Then I can do I didn't make data, but yun15f. Okay, that is connected. It's connected, but I do not have any reference. I need to have a label. So by connect, then I need to use that connection. Therefore, I need to assign that connection to a label, in this case DB. Then I connected database, and then I need to create a cursor. So db dot cursor, it creates an cursor object. As I said, I need to have that cursor object throughout my execution of database language within Python. Then I need to have another object reference, which is called the C. Then I have C. Then I can create star dot select star from student, as we looked at. But this will create a lot of errors, right? So, for example, SELECT doesn't make sense to Python. That language, this language doesn't make sense. Actually, it makes sense if we have, for example, Python understandable language, which is execute, right? So that I can put I can call that function as execute. But execute itself is not, the Python does not know execute what. We need to execute the cursor which is connected to a specific database right now. So we need to use that object, cursor object. So it'll be c.execute. Yet this itself is not running. That execute function has some issue, which is it should have 3 dot dot dot. This is just a language. 3 dot 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 between. SQL statement is a database language. Now we are working on the host language. So there is some delimiter. So dot 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 in between. And then enter. Then I have some returns, right? Can I see that some return? Then you need to receive it so that you can say return equals c.execute. Now you need to cook that returning stuff. Enter. Oops. Invalid. There is another. Okay, here. So what should we do? Okay. All right. This is the language. This is not going to work. So we simply execute it. Then return this returning table is available in our memory. So we need to grab that memory, which is cursor fetch all command. Cursor fetch all command. Then it'll grab that returning table. Okay. Can we see that all content in that fetched table? Where, yeah, we can see that for row in that table, I want to see, I can print simply row, see what happens. Then those are the returning. This is a command. What happens here is that first we need to connect, and then create a cursor and execute database statements. In this particular case, because this is SQL, it returns the result of that execution. If you want to see that result of execution, then this is the language that we need to. Under the for loop.
Can you explain what the command db.cursor does again?
Okay, DB is a connection to database.
Yeah, that's. Yeah.
And then cursor means after connect, then file pointer should point to that database entry point. There's a pointer. So that pointer, this is nothing but pointer to that database. This pointer now execute this statement. Let's say this is the database. There is a pointer. Then I'm not going to execute that as that statement in another database, but this database.
I guess it's, you can set the variable, multiple variables to multiple databases.
Exactly. As I said earlier, database engine can have one or more databases.
And then I have one more question. Why did you do the multiple apostrophes for before select and after student?
That's a language.
You just have to do that.
Yeah, yeah. Dot, both ends. See here, this is a statement dot. That describes in here. If you want to create table, again we have a dot and dot. And inside, typical database language. You're welcome. Insertion is a little different. If you want to insert, so many different ways of insertion. You can insert one record at a time, but this example tells you if you have multiple records, then you can put that multiple records in the list form of Python. Square bracket. Remember that square bracket has a multiple parentheses. Each parenthesis represents a tuple. So list contains a number of tuples. Each tuple is Python data structure language, right? Each tuple contains multiple data. Each data is for a specific attributes. So number one, that is, let's say, CWID, and John is the name, and this is telephone number, and whatever that, right? Okay. By the way, this is it. We're done for this course. So finally, we did 3 ways of by using graphical user interface and from the command line, and third from the local language in our case. So all example programs available in this textbook. So you can use it. I will need to practice next 10 minutes. So from 11 o'clock, we'll go to the review of the program. If you have any questions, so we'll take 10 minutes. Okay, your final, I posted it. The final will cover from the first lecture till today, but it doesn't mean that you have to study, for example, the very basic Python language that we uh, covered and also tested on the midterm exam. I may ask you a similar question that you already took in the midterm exam because that way you can make sure your skill sets more. So I may ask you maybe one or two questions from basic Python. Okay, one or two out of about 10. Okay, I may ask you about 10 questions, one or two from basic Python, Python itself. Um, Back to the goal of this class. I want you to build up your coding skills and have some basic concepts of three fundamental the courses: network, uh, database, and operating systems. Right? Those three fundamental the courses. So those are here. If we are talking about textbook, then you can say Python accessing operating system, Python accessing databases, database server, Python accessing networks. Basically, what I want to ask is operating system concept itself, one question, and then Python capabilities that can do something on or something with the operating system. So there will be two questions. One purely the concept itself, another with the Python. Same thing, database servers, then I'm going to ask you database concept itself, and then a little bit of hands-on. Remember that we did the three types of hands-ons, right? I may ask you, for example, we have three ways of accessing databases. What are those three? And then and then I can say this. I would say blank command line and blank. And then if you do command line, then how can you do this? Then I can say you can also answer something in command line access, right? Network, this is tough parts, right? Network is very, very important, getting more and more important. Although I asked something already in the midterm exam. I'm going to re-ask you something about network concept only, and then something in Python or something in Wireshark maybe, which is easier for you, right, than Python. A question about Wireshark may not be easy. I'm not sure. I didn't decide, but actually, the way that I ask you is for each subjects here, those are three subjects, two questions, at least two questions. One question purely the concept itself, another question a little bit of integration with, say, Python or graphical user interface or any applications that we did. applications, for example, network, then we did a little bit of Wireshark. Although we didn't do a lot of Wireshark, we don't need to, right? If you click one after another and another, then you will see. Only thing that I ask you to understand is you need to know what it means. If you have some bits and bytes of packets, then you understand what it means. Because this is open book and open resources, I may ask you, for example, what is this? Then you may need to look for that information from some website, right? What is that one? Network sorcery? Yeah, right. That type of things. That is very, very important. Not only for this course, but throughout your life. If there is a TCP, then you need to have a TCP standards, and each bits and bytes should be interpreted. If that is IP, then same thing. UDP, all details.
So we have 8 questions, right?
Yeah, about that. Yeah. Do you want me to ask you 2 more questions? For example, tell me your winter plan. 1 question.
How many questions do we have?
I would say big 8 questions. Big means some question itself. Some question might have sub questions.
Oh, so operating system, database, and networks are going to have some questions.
Correct, yeah. Well, 2 questions, but each might have sub questions. The reason for that is this is not just evaluation. Many times, the way that I ask sub questions, in that order, that is the way that you need to solve. I may ask you to answer the last question itself, but sometimes students do not know what to do. Then I put some steps, and those steps are in that sub questions. I don't know if you noticed that, but I always do that. When I ask sub questions, then those sub questions are in that order. That is the order that you need to do always. Although you are asked to answer the last question of that sub question, you need to through those steps. So in a way that I give you some hints, and in a way that I want you to get some lesson. Okay. Any suggestions? Any suggestions that we could improve this course, for example, for the next generations? Exactly. Extra credit. I understand. Yeah, I understand. Yeah, I do. I try to give extra credits usually, but yeah, sometimes students do not want to receive extra credits by expressing no extra work. If you do extra work, then I usually try to give you extra points. Eric.
I'd say maybe more assignments and make them a little more incremental. So just to get people more confident in your coding abilities. Obviously, everybody before coming here should have taken a coding course, but maybe the first assignment, a little more baby steps on these assignments.
I see.
I didn't find them unfair.
I understand. Yeah, I understand.
I do think maybe for someone who hasn't had less.
What if I would do my textbook? There are some examples and exercise. If I ask, oh, from the beginning, you should solve all the exercises.
That might be a little broad. If going, I think it's a broad, if you you say you should solve all the exercises, then chances are someone might not. If you say you have to do this one, you have to do that one, it might be
Yeah.
an incentive.
Cards posted in the Blackboard, like most of the chapters that you gave us, like I have posted in the Blackboard right now, since we're finishing the class. So because I missed number 4, so since I missed that,
Number 4 means graphical user interfaces.
yeah.
Chapter 4 or
Yeah, chapter 4.
chapter 4?
You want the digital copies, what you're saying?
Yeah. Oh,
That'll be nice.
because the show we missed, we just can't put it in the library. Much easier.
Good idea. Online students usually receives.
I know, they see it. So now since we're finished, I know you didn't do that because you want us to practice coding. It's good, but since we're finished with the class now,
Right.
why not do both?
I'll take that into account. Any comments, any suggestions so that next generation of textbook will be improved? I know I was expecting some comments from you, particularly if you see some, because I do not, this is, while I was teaching, this is first addition. It's not really addition. It's not. It's -2, -2 addition. It's not yet addition 1. Okay. So a lot of errors and a lot of. I think it has a lot of transition issues. So one topic to another topic. Because I'm the alone writing, and I write something. Oh, I should do this, and I jump to that issue, and I forgot to fill the gap. So that type of things, if you let me know before the end of this semester, then you will receive credits.
So we have to run all codes.
Your first one will receive credits. So far, I have only one credit from one comment from Eric. But I want more constructive comments, not just saying, "Oh, this is a sucks." Then I cannot improve. What should I do? Destroy? Make it constructive comments and suggestions so that eventually next generations of students will learn better and more effectively, efficiently.
Like you wrote the final chapters, I'd be interested in seeing the rest of the book.
Those chapters?
Well, yeah, final or the financial, healthcare, and
Oh,
services.
finance.
I'd be interested in seeing them all. Have a complete book.
Financial. Yeah, I did.
We did that with the
That is, oh yeah, I did that. For example, yeah, something that the power of Python is that you can populate in Excel, for example, and you can save that Excel to a file back and forth and bring it to any text formats. And finally, some of this not available in Windows. You need to go back to Linux. I think I should say some here. Reason for that Linux operating systems issue, I didn't do much here. For example, if we link that to bridging from Python to R, this is statistical application, then you need to do, you have to do this on Linux. There's no way that you could do on Windows only. Okay. So some yes, but not all. This only this accessing and real ones will be here, but I didn't do anything for these chapters. Maybe I may do this if I teach some courses related to this. But I may do this. I was thinking of do this if I teach 550 intrusion detection, but because we have a very good adjunct member, so I'm going to ask him to teach. Originally, I planned to write that chapter while I'm teaching intrusion detection and prevention. I've taught only once. At that time, we used Python to detect and prevent intrusion. But all depends on the instructors. Some instructors don't do much of skill sets. Some instructors do, but application programs. Some instructors do more than application programs. Some coding as well. Okay. Any other? You want to email me, text me. Or you can do that, yeah. Mhm. Some chapters needs more examples, right? So point me, for example, oh, this chapter needs more example, more explanation. That much still help. Don't say that in general you need to have more examples. Then that's too much, and also not clear which one that I need to add more. But if you point out, oh, this section, this chapter, we need more example, more explanation, then I can quick improve it, right? That type of suggestion is constructive. So that is your extra credits. Get your extra credits. Yeah? Give me some comments. Constructive comments. Why not? You don't need to bring, oh, this is the example. I can, or yeah, more specific suggestion might be, can you create some examples in this application, for example?
I have a question. You downloaded Python 2.7 for this course, right?
Correct. 2.7 and 3 point whatever recently. Right now, 3.6, right?
3.9, yeah. Did you ever use 2.7?
2.7,
In the class?
we didn't do, while you are developing, some cases you have to go back to 2.7. Almost all the languages, it's very funny. 2.7 can accept 3.4 languages, but 3.4 language does not accept 2.7 language. Very interesting. But 2.7, there are almost complete application and development and implementations in 2.7. So if you go back to 2.7, then you do not have any issue. But it has fundamental issue itself. As I said, 2.7 is not functional programming language. Anyway, eventually you need to come back to 3 point some financial applications. If you want to import some, then 2.7 on Linux is is the only way that you can do. Okay, if you do not have a question, then this is it for this semester. I wish you have a good winter break and see you in the real winter in January.
I never seen any emails about the fine.
Announcement.
Oh, the announcement.
Yeah, announcement. Yeah, you remind me always if you.